We already know we can find the length of a hypotenuse by using the Pythagorean theorem. We can also find the length of a hypotenuse by use of a form of the theorem called the distance formula. The distance formula treats the slope of a line like the legs of the right triangle and then completes the calculation of the Pythagorean theorem. In this illustration of a line, we have the legs of the line denoted in a right triangle. We see that they are 3 and 4. If we drop those into the Pythagorean theorem, we find that the length of the hypotenuse is 5. If we use the distance formula and we drop the points in themselves, we also find the distance between the 2 points is 5. So we can get the same result with fewer steps. In example 88.1, we're going to use the distance formula to find the distance between 4, -2 and -5, 3. So first we write in our distance formula, then we drop in our points, and we calculate those two as 81 plus 25, and we find that the distance of the hypotenuse, or the length of the line between those 2 points, is the square root of 106. Algebra is one of the courses that will help you with problems you'll encounter in chemistry and other higher sciences. Getting an awareness of how to solve these problems before you get to them will help you out in the long run. One of the problems you'll encounter is the relationship of PV equals nRT. This is one of those gas law type problems that you're going to encounter over and over again. So you need to go ahead and write this formula in your reference. This formula has 5 variables that stand for pressure, volume, the number of moles of gas. R is a constant with a specific value of 0.0821, and T stands for temperature in kelvins. In example 88.2, we'll use the relationship PV equals nRT to find the number of moles in an amount of gas where the temperature is 273 kelvins, the pressure is 1 atmosphere, and the volume is 8 liters with the constant of 0.0821. So we have our formula. We're going to divide by RT so that we can isolate N by itself, because that's what we are looking for, is the number of moles. Once we have our manipulated formula, we can drop in the values for each of the things that was given, the temperature, the pressure, the volume, and our constant. And then we can actually just whip out our calculator and perform the calculations, and we find out that the number of moles is going to be 0.357 moles. In example 88.3, we're going to use this formula to find the volume of a certain amount of gas at a pressure of 3 atmospheres. So we start with our original formula. We divide everything by P. That allows us to solve just for the volume. So V equals. Now all we have to do is move on to dropping in our values. So with the original formula manipulated to V equals nRT over P, we drop in the values that were given, and then we calculate them to find that the volume is 9.11 liters. So let's review. We can find the length of the hypotenuse through Pythagorean's theorem, but to use points of a line to find the length of the legs, to do so, we use the distance formula instead. When we use chemistry formulas like PV equals nRT, we manipulate the variables to isolate what we are solving for, then drop in the numeric values and calculate. As always, thanks for joining us at Jupiter Math. For more information about our math programs, contact learning@edugraphics.com.